Hello, and welcome to the third part of our paper that talks about bias in facial recognition. Facial recognition systems have become widely used across many fields, such as surveillance, criminal identification, access control, and airport security, for example. However, one of the biggest challenges these systems face is racial bias. They often perform unevenly across different racial groups, raising serious ethical concerns. In this study, we compare racial bias between two approaches. Deepface, a popular high-level facial recognition library that uses pre-trained models, and ResNet 18, a general-purpose convolutional neural network trained from scratch. Our goal is to understand which approach is fairer and how racial bias manifests in each. So, okay, most studies focus on models trained from scratch using full facial recognition pipelines, but one important area that still underexplored is the use of high-level encapsulated libraries like that Deepface, which use pre-trained models, combine multiple architectures behind an abstracted interface, are heavily adopted in real-world applications and lack fairness evaluation under a racial bias perspective. So here are our research questions. Which model shows greater racial bias? Which racial groups are most negatively impacted by each model? And are there common patterns of bias shared between those two models? Okay, so first, we selected the Farface dataset, which contains a diverse and balanced set of face images from multiple racial groups. From this dataset, we extracted a subset of around 5,000 images, inserting about 215 images per racial group to maintain balance. And next, we performed the step of dataset splitting, dividing the data into training and validation sets while preserving this racial balance. And this split was used then differently depending on the model. So for the ResNet 18, we trained the model on the training set and then validated its performance on the validation set. So for the Deepface, it is a pre-trained library. We use the validation set directly from the evaluation without additional training. This approach allowed us to fairly compare a trained from scratch model, the ResNet 18, against a widely used pre-trained tool, the Deepface, focusing on their performance and potential racial bias.
So I will now answer the research questions. The first question is, which model shows greater racial bias? Looking at the confusing matrix, we can see that Deepface shows more racial bias. This is evident from its lower values on the main diagonal, indicating more classification errors, especially for Latino and Indian face, while ResNet 18 correctly classifies more faces overall. The second question is, which racial groups are most affected by each model? Looking at the same confusion metrics, we can see that for Deepface, the most misclassified groups are, in order, Latino Hispanic, Indian, and Middle Eastern. For ResNet 18, the most affected groups are Latino Hispanic and Middle Eastern. The third and last question is, are there shared bias patterns between the two models? As you can see in the confusing matrix, both models have the highest misclassifications rates for Latin Hispanic and Middle Eastern face, showing a similar bias pattern. In conclusion, this study investigated racial bias in facial recognition systems by comparing DeepFace, a pre-trained model, with ResNet 18, trained from scratch on the balanced Fairface datasets. How you can see, DeepFace showed greater overall racial bias, with more misclassification across several racial groups than ResNet 18. The most affected groups were Latin Hispanics and Middle Easterns. And finally, for future work, we suggest expand the evaluation to include more advanced frameworks and architectures, and analyze intersectional bias, for example, race combined with gender or age.